So, welcome to Transform 2021, and I would like to thank our sponsor, Studio X. And it's now my pleasure to introduce you to Anne Estoppey, who's going to give you a friendly introduction to NLP. So, Anne's background is in geoscience, GIS and data management in particular. She holds a master's degree in geology from the University of Geneva in Switzerland. But she's actually been living and working in Norway for a number of years, and she's got over 10 years of experience in the oil and gas industry. Now, a few years ago, in 2018, she left her job and started to self-educate in data science and Python. And since then, she's also been working as a contractor for operating companies in Stavanger with geospatialization, data flow automation, and geodatabases. And so her interest in natural language processing has grown lately as NLP is becoming more popular in the industry. So she's got loads of cool stuff to show us. I'm going to hand it over to Anne. But before I do that, let me tell you there's information about how to communicate with Anne during and after the live stream in the description in the YouTube video. If you're watching this live, you can also join us in the Slack channel. There's a link to that in the YouTube description as well. And Anne will be joining the conversation after the video in the Slack channel. So with that, over to you, Anne.
All right, so I will share my screen. And thank you, Rob, for your really nice introduction. Let me first do a little full screen, etc. things. Okay, everybody, so here we go. Thank you for joining. So again, thank you, Rob, for the really cool introduction. I know Rob from the Force Hackathon in 2018. So in 2018, I did quite a bit of new stuff. That was really nice. I can start to add a little bit by saying why I got interested in NLP, not only, let's say, work-wise, but also a little bit more personally, because I always like to learn languages. So I've been learning a few languages through the years. And yeah, I thought that would be a nice new approach to languages. Why not? Having a look at natural language processing. So I will start this notebook with talking a little bit about the data, and then I will also tell you what we are going to go through in this notebook. I might try to zoom in a little bit. So I got a message that it might be a little bit too small. Let me have a look at that. I hope this is better now for everybody. So in this Jupyter Notebook, we are going to explore different aspects of NLP, which is what I'm going to use instead of saying natural language processing. And we are going to use REL reports summaries, which are published by the NPD. So NPD stands for Norwegian Petroleum Directorate, by requesting via an API. So the Norwegian Petroleum Directorate makes available their data on a public repository. And it is possible for anybody to use this data, and you can download the data, and there are also shapefiles, for instance, or you can use an API and just run some simple request. We will go through the different stages of text cleaning and formatting before moving on to NLP processing, which is tokenization, lemmatization, and finally topic modeling. The level for this notebook is intermediate, so we expect people to be a little bit familiar with Python. Please see the requirements and the different what's necessary to be running to make this run. If you have issues, please let us a note in the Slack channel. What I would like to say here as well is that I'm not holding a PhD in natural language processing. I'm a sort of back-end geospatial data manager. That's the best I could come with as a short definition of myself work-wise. So there are a lot of things that I will go through, which of course require more investigation on your part. It is a kind, as we know with machine learning, NLP is also a vast domain. So there is plenty to investigate further. So please do so. The data precisely that we are going to look at, there are two data sets. So the first one is the well report summaries, which you can see a link here on this repository. And the other one is actually, we are going to look at the wellbores, which is a general kind of data set, which has wellbore names, a lot of general information and coordinates. I'm going to say a few words about specifically the libraries that we are going to use. Again, there is a lot of documentation, have a look at it. For the language model we are going to use a language model from Spacy. It's an open source library and it's for Python. We are going to use the latest version of the language model, which here you can see, you have to install it locally and then you will be able to use it on your machine. So that's very nice because the language model itself is not that big. They have different types of language models, different in sizes or different how they compile or generate them. So again, there is a lot on their website. Have a look for the details. We are also going to use Gensim or Gensim, I'm not sure how you pronounce that. And it's a Python library for topic modeling. It's also open source. It's for, you can do a lot with Gensim. We are going to use a few functions. You will see later. It's the documentation, I must say, is quite nicely done. It's very readable and you learn as you read the documentation. So this is quite nice. Finally, we are going to use a visualization library, which is called PyLDA-Viz. And it is designed to help users interpret the topics in a topic model that has been fit to a collection of text data. So that sounds a bit obscure, but you will see it's not that. So in this case, I used, for the requirements, I'm using Jupyter Lab. I'm on Python 3.7.4. And I used the version of PyLDA-Viz 2.1.2. There is Rob, who introduced me, who has tried Python 3.8 and the latest version of PyLDA-Viz, and it worked fine for him as well. But please, again, if you have issues with installation, etc., let us know in the Slack channel. About references, just before we start, I have been using or referring to a notebook that has been done by Michael Dowling, and he was presenting his topic modeling at the Python Ireland meetup a couple of months ago. And I got really inspired by what he did, and I thought I would like to try to do something similar, and then therefore I chose the well report summaries because I thought that would be interesting to try the same on different type of data. There are also a couple of articles for understanding better topic modeling and what is LDAVS. I will come back to later to these these terms especially. And 2 books here for generally about natural language processing. I would recommend these 2 books as well. Have a look. You can always download the samples from Amazon and have a look at them. So briefly, after we will have downloaded or get the data set in our notebook, we are going to reformat these data sets using pandas data frames. We are going to do some visualization on maps to have a general look how our data is distributed. We are going to do some cleaning and more cleaning and pre-processing with removing stop words, tokenization, and lemmatization. We are going to do some further exploration with using word clouds. And finally, we'll come to the topic modeling. We will have a break in about half an hour, a little bit more maybe, depending how fast or slow I'm talking. I will check the time, and I will definitely tell you when the break is coming. So how I was thinking to do is I have a number of cells in this Jupyter Notebooks. I'm not going to go through every line in every cell, so I'm going to run these cells again so that you can have an idea what's going on. If I have an issue, I have run this Jupyter Notebook before, so we will be able to continue. So without no further ado, as they say, we are starting in the notebook now. So first we are importing all the different libraries. Some of them I mentioned to you in the introduction. I'm not maybe going to say, like I said, explain every bit from every cell, but if you have questions, again, please use the Slack channel. At this stage here, we are going to establish a connection using the API that will go to the repository, this data Norge, where the data from the NPD sits with the wellbore data. So here first, I'm running a test to see response 200, code 200 in HTTP means that everything is good. The API is up and running. And then we are going to start to have a look at the well summaries, which in the repositories are called with history. It's a table called with history. So, but this is the well report summaries. We want first to know how many well summaries we have. So here we see that we have 1828 well report summaries. I will also just use the word summary sometimes, it's shorter. We see that the data is paginated. It means that we will have to loop through these different pages to get all our data in our data frame. And that's what we are going to do right now with this function that will allow us here to get our data in our data frame. This data frame, we call it data frame all summaries. So again, we see that we have 1828 rows. It looks like that. It's fairly simple. There is a date when it was updated, the wellbore name, so WLB means wellbore. The names are very according to the NPD's convention, so it's official names. You have an ID here that we're not going to use, and here are the first words for each well report summary. And this date here indicates that actually this table has been updated today. Are we the 19th today? And it means that the NPD is updating their data on that repository all the time. So that's very nice. This data I found from the NPD is quite good quality, but we can still check to make sure that we do not have duplicates. By duplicates, I mean wells that are appearing twice. And we see here, according to the wellbore name, that we do not have duplicates. So this is unique wells for the well report summaries. Now we can be a little bit curious and pick one of this summary from the data frame and look a bit how it looks like. So you see, okay, with a bit of effort, you can read it, but there is a lot of tags, HTML tags and other text formatting tags that we definitely want to get rid of. So we'll see about that. Now we are going to get the data set which has general information about all the wells for the whole continental shelf in Norway. And this is really all the wells. So we'll immediately see that we have 8,494 wells or rows in this table. So we get in with the same function as before. Of course, there are 8,000 rows, so it takes a few seconds. And here is how the table looks like. So our data frame with the coordinates is called df all with coordinates. And we see that we have a number of information. We have 26 columns. Not all of them are here. But mainly, we know which kind of wellbore type we have, if it's exploration or other, in which UTM zone it is. We have when they started the well, and we have information about coordinates, both in decimal degrees and in UTM coordinates. So, and of course, the name of the wellbore and what it contains, if it has shows or oil or gas, etc. A geodetic datum that could be also of interest, and also the main area. Here we have at the very end of this table, if we are in North Sea, Norwegian Sea, or Barents Sea. That's the three main areas. So, and sorry, we also have an operator here, just in case. So as you can see, this general table has a lot of information. So again, here I must say that this is really good or good quality data, very usable. So thank you for that to NPD. Somebody from NPD is listening. Again, I will quickly check if we have any duplicates in this table, and we do not have. Here I do a little, what I call a little coordinate gymnastics, because all our columns are of type object, and we are going to use our coordinates, our decimal degree coordinates here. And of course, we want this to be numbers, or more precisely, float numbers. So that's what I did here. And we can see now that we have the latitude, or the north-south decimal degree, which is a float. And here we have the longitude, which is the east-west decimal degree, which is float. So that's perfect. We are going to be able to use that on a map. So shortly about the map I'm going to show you, I have done it with Plotly Express. So I discovered Plotly Express via Ashley Russell, who did a presentation just before this morning. And Plotly Express is a very nice plotting library. It's compact. You can quickly do graphs and maps, which are a bit interactive. And by reading the documentation, you can also quickly set it up as you wish. So for me, it worked quite well in this context of this notebook. So what do we have on this map? We have all the wells that are in our table with coordinates, so the 8,500 wells. The different colors show the different areas. Like I told you, I'm going to do like this, so we see a little bit everything. The North Sea is in blue, Norwegian Sea orange, etc. So we can see already that we have a fairly large density of points for North Sea area, and a little bit less maybe for Norwegian Sea, and a little bit less for Barents Sea, but it's very scattered. That's as expected. So here I can see already that the data looks, the geographical aspect of the data looks good. It shows me that there is no points that might be somewhere else. I checked with the world map. So this is just to have a quick QC, and also you can start zooming in and out and etc. in this map just by using your mouse or your cursor, if I find a way to do it, because I'm not using mouse. And if I zoom on the different points, for example, I chose myself to have this pop-up box this way with the well name or the wellbore name, what it contains, here oil and gas, and what kind of well we are talking about here. It's an exploration well. So it's kind of practical just to check out stuff, I would say. Now, yeah, here it was just to show you the different areas that we can extract from the data frame with the coordinates, which are defining the areas for the map with the colors. All right. Now we are going to merge the two datasets. So the dataset with the summaries and the dataset with the coordinates. It's a simple pandas merge where basically I will drop all the rows which are not common to both tables. So it means that at the end, we are going to have our the same number of rows that we have report summaries, which was 1,828. I also picked a few columns only from the coordinates data frame because there were many, as we saw. And the result is a table like this, where now we have included the coordinates together with the well summaries. I run again the map just to show you a little bit the difference now, because we went down for 8,500 points to 1,800 something. So you can see again that the density is a bit the same, that there is more data in the North Sea than in Norwegian Sea than in the Barents Sea. But the Barents Sea has lost a lot of wells because they didn't have any well report summaries. Okay. So that was just the first approach to the data. So now we are going to start cleaning the summaries. We saw that there was a lot of HTML tags and other text formatting tags, and we are going to start removing this information which is of no interest for us. This is just a control point here, and to make a copy of the data frame. So we start the cleaning here in the cell, and you can see that we are removing this character or string and replacing it with codes and so forth. Sometimes I have to stop to just drink a little bit of water. So I can we can have a look then at the data frame, which now I rename clean. So here is our original summary, and at the end now we have a new column with the clean from HTML tags, etc. At the end of the data frame. So that was a raw text, and that was our sample when after it has been cleaned. It's just the first summary in the table. So you can see that we were there and now we are here, so it's a bit more readable. We'll see what happens next. Okay, now we are starting the more in-depth pre-processing for NLP specifically. So what we are going to do, or what we have to think of, is that we are going to create a separate data set, if we wish. We will see how that goes, in order to be able to create our word cloud and also to continue with our process in the NLP part of this notebook. So we are using the data frame with the summaries that we have cleaned just above. Here I was interested to know the length of the summaries in general, because just to know what are we talking about. Are these summaries super long, super short? What is in average the number of words they have? And we see that it's about 400 words. So that was also an indication for me to know if I could follow what Michael Dowling, the guy from the Python Ireland meetup, has done, because his texts were about 250 words. So I wanted to know if I was in the same order or not at all. And I figured, well, it's in the same order, so I'm going to continue to follow more or less what he did. Here we are going to pick a well specifically, so that we will use that well further down, so then you can follow a little bit what happens while we are cleaning and processing for the word cloud. At this point, we create a list of strings where each well summary is a string. So here I have to make a little note for you guys that at this stage we decide to handle only the well report summaries, and we will not continue with the geospatial aspect of the data frame. Therefore, we group our well report summaries in a list. So this is important here, because you might think, what is going to happen with this geospatial aspect of the data frame? At this point, I dropped it to continue only in natural language processing, because, well, I was a bit running short of time. And also, of course, there are many possibilities what to do next, so we had to limit ourselves a little bit. So there we go. So we are now creating a list of lists, and in each list there will be one well report summary. Here again, I take one example, and this is our well 121 that we were looking before. So it's still looking the same. This is great. And we continue the cleaning. This time we're using some regex. So I'm not a super expert in regex, but I know somebody who is, so I can tip you if you need somebody who is an expert in regex. Anyway, so here we are going to remove some more characters, special characters, etc. And now for this same well, we start to see that the text looked very clean, but we are losing a bit of information because the slash are missing, etc. So we'll see how that goes. That's a choice we're doing now. So that's a bit always the same with machine learning and NLP. You have to make choices, and then you have almost to run through the whole thing to realize if your choices were good choices or not. So that's what we are going to do here. Here, the next step is an important step. So I will just run this function. We are actually transforming our text into a bag of words. So we are actually doing a tokenization. So each word we had here in our text is now a token, plus what do we see? All the numbers are dropped. So I read the documentation. You can see here we are using this gensim-util simple preprocess function. So I read the documentation and saw that when you do that with this library, you actually remove small words or words that are really too long. But the result is that I can see here I still have small words like of and to and was and as, but the numbers are gone. So first I thought I'm not quite sure about that, but then I thought, well, let's see what happens if it's really critical for me, for what I want to achieve later. Now another part which is important for pre-processing is to remove stop words. So stop words, sorry, I have to scroll a little bit back. Stop words are small words or words that do not contain information in themselves. For example, at, to, be, was, of, is, etc. So we want to remove these words from our bag of words. And also we are able to add extra words that we want to remove. And by running a few times this process to create my word cloud that we are going to see in a minute, I saw that these words here were very ubiquitous and were kind of masking information that would be more relevant, in my opinion. So, of course, here you can add the words you wish to remove from your bag of words. So again, it's a bit, you have to do it iteratively and try several times to see what you think works best. So that's what we are going to do now. We are removing all the stop words plus the extra ones. And now we see that we are still with the same well. We see that the information is somewhat condensed. So it's a bit like when you cook a sauce and you want the water to evaporate and then just keep the strongest tastes. So it's a bit like that here. You can see suddenly that, just like that already, without processing the word cloud, you have a lot of oil words in this bag of words for that well. You can see here and here and there and there. So must be something about oil here in this well. And you have an indication about fluorescence. So, okay, that's quite interesting to see. So here we are creating the word cloud per se. So, in fact, I'm just following a method that I think I Googled it, and maybe it was also from the notebook for Michael Dowling. So it's just steps you have to do to create your word cloud. So I'll just go through them without too many comments because it's stuff you have to do to be able to generate and display your word cloud. So here we go. And we have a little definition for the word cloud. And at this point for that well that we're looking at, we see that the word cloud result is this one. So yeah, try to remember that we have apparently an indication of oil and water and seawater. Yeah, so the Paleocene is here. I was trying to locate it before, so I see that's an indication here. So that's quite a result here. And I'm just having a peek. Yes, we are going to have a break of 10 minutes now. And I will let this nice word cloud for you to contemplate. Yeah, so see you in 10 minutes. All right. We are back on. Let me do the regular things. So here we are with this nice word cloud that we just saw 10 minutes ago. So we are going to continue our NLP journey. At this step, we are going to process all summaries. We had before a list of lists, which we called bag of words, no stop. And it is, as I explained, it's a list of a list where every element is a bag of word for each well report summary. So we can check it out here and you see that it's a list. Now I'm going to introduce you to a few concepts that are very useful in NLP. It's going to be quick introduction. First of all, about a corpus. So when we talk about a corpus, we talk about a collection of all your texts or documents. So here, this is all our well report summaries. Also, very often, people, and I also do that, we use interchangeably token and word and term, but it's the same. It's the smallest unit of text, which is a word. So it's also a token or maybe referred as term. As we saw, a tokenization, a little bit more formal definition, is splitting a phrase, a sentence, a paragraph, or an entire text document into smaller units, such as individual words or terms. Each of these smaller units are called tokens. So a little recap here. Now, a little bit about lemmatization and stemming, which are two rather large topics in NLP that I will really introduce quickly here. So bear with me. Lemmatization is the process of converting a word to its base form. The difference between stemming and lemmatization is lemmatization considers the context and converts the word to its meaningful base form, whereas stemming just removes the last few characters, often leading to incorrect meanings and spelling errors. For example, lemmatization could correctly identify the base form of caring to care, whereas stemming would cut off the ing part and convert it to car. So there you go, we are getting into NLP and you see that already there are some things to consider and to keep in mind all throughout. So you can see here the example for carrying. The lemmatization gives the right root form, which is coming from care. It would be also, we could take cared, would be also give the word care or the root lemma care. We call a lemma this root. And if you use the stemming, definitely something happens here which is unwanted. The caring's root becomes car. So I had some thought about that, and knowing this, I would say that lemmatization is a more correct way of treating text. Stemming seems to oversimplify. On the other hand, stemming could be a way to process large amount of text more quickly. Possibly one way to avoid word ambiguity with stemming would be to use bigrams or trigrams, which are association of 2 or 3 words together in order to give context. In this notebook, we choose lemmatization since we are not running on a GPU, and working with bigram and trigrams is very processor intensive. So here am I on a MacBook Pro. I do not have GPU. Also, our corpus is not that big, so I think lemmatization sounded a bit more, correct in a way to use. Now, a quick introduction to part of speech. It's also a term that you see a lot in NLP, and you don't really know what it is. It's abbreviated POS, and it's also called grammatical tagging. It's a process of marking up a word in a text as corresponding to a particular part of speech based on both its definition and its context. So here you can see I have a little image here, which is doing part of speech online. So you go partofspeech.info, and you can write in a text here, and it will for you indicate the different part of speech. So here the phrase is John likes the blue house at the end of the street. So John Mark is in gray, and house and street are nouns. The verb likes is in green here, marked as verb, etc., etc. So this is really cool to have an idea how part of speech are working. Have a look. Now, a few words about Spacy. Spacy is a pre-trained language model, and in this notebook we are going to use the language model which has the following name here. This English core web means that they have generated the language model by using text on the web. SM means small, and that's version 3 of it. So like I indicated at the beginning, you install it locally, and then you have fully access to this language model, which is, I found it personally quite cool. Another very known language model that has been talked around a little bit is GPT-3. So I think it was last year in fall, I managed to get API access to GPT-3. And then they have a sandbox where you can play a little bit around with it, do different things, test, etc. And GPT-3 is a very new and incredibly crazy language model. So hey, I just thought, well, I just asked directly GPT-3 question in the sandbox. It's a bit like a job interview, you know, they ask you can you introduce yourself or something. So here it is the same with GPT-3. I asked it about itself. So that was a bit funny to do. So I asked, what is a pre-trained language model? And GPT-3 answered, a pre-trained language model is a language model that has been trained on a large amount of data. Next question, what is a language model? And GPT-3 answers, a language model is a statistical model that estimates the probability a word given context. And this is really important to keep in mind that when you do natural language processing, you won't at all times try to keep context. You don't want to treat words as you don't want just to count words, but you want to keep a context to each word in relation to other words. And here also there is a lot about that. If you read articles and Google it, it's totally interesting and fascinating, but I don't think I want to go in that depth right now. But please, yeah, check it out. It's really quite, interesting fully. And the last question to GPT-3 I asked in this batch is, in which context do you use a language model? And GPT-3 answers, a language model is used in the fields of machine translation, speech recognition, and information retrieval. So, of course, for us in geoscience, information retrieval sounds quite relevant. So here we are simply going to load our model, which you can see on my machine is in this path. And if we check the type now of this model, it recognizes it directly as language model, spacey language model in English. Okay, so I hope that you are still following along after this quick introduction about NLP, words and world. We are going to continue now with our well report summaries. So there, in this next step, we are going also to try to continue to boil down what we have to the most essential. So we have already removed our stop words we saw above. And now we are going into lemmatization. So we are creating a part of speech. And then that will allow us to select a specific type of word. Here we are going to be interested in the type noun. So here we go. And we are going to have a look what this bag of words with only nouns, parts of speech noun, is going to look like. It might take a few more seconds, but you can see the result already here. So suddenly we have really, this is still at the same well we are looking at. We are looking at something which is much more condensed. So I was like, okay, how could I compare to the other one? And that we had, where we had all the different parts of speech. So I decided to run a new word cloud on this same well. And we'll see how it looks like in a second. And now it looks like that. So I will scroll up a little bit so that we see the one we had before. So I'm sorry to scroll, but bear with me. The first version with all the parts of speech from the bag of words, we had this. So you see there is a lot of noise. It looks much more untidy, but maybe there is some information which is also important, even if it's not in larger words. And we have this test oil water that really comes forward. And now our word cloud with only the nouns look like that. So I thought it's not too bad. Yeah, the Paleocene is still here, you can see. And a priori, I thought that I was on the right path to just consider the nouns for each well summary bag of words. Here we can do a little a quick sidetrack where we are going to inspect the most frequent terms from our lemmatized bag of words. So that's all our well report summaries together, and we are going to see what kind of words are coming first. So we create a CSV file in the cell before, and then we are going to display it as a data frame quickly. And you can see that the terms that are the most frequent in the whole collection or corpus of well report summaries that have been lemmatized by noun. The first words more frequent is oil, and then you have gas, and then you have test. So you have the frequency here. And then you have about, I can tell you, 3,800 different words for this corpus. So, okay, that's just an indication that you can keep in mind to know where we are a little bit with these words and what kind of frequency we attain for the whole collection of reports or summaries. Because now we are going to do another processing, which is to create a document term matrix. So here you have to bear with me because it's not super intuitive at first. But this is going to be used in the topic modeling that we are going to do further below. So first of all, we are creating a dictionary with our bag of words which have no stop words and that have been lemmatized. And here, this is where we have to be careful. We are going to filter extremes from this dictionary. So the first parameter is this no underscore below. It means simply that here we chose 5. It means simply that the tokens or words appearing less than 5 times in all documents will be removed. So it's a choice. You can choose that, put this number higher or lower. You can, again, you have maybe to try a little bit. But for our case, I found out that 5 was quite fitting quite well. And now there is another parameter, which is called no underscore above, 0.5. And this is a little bit different. So I have written here, I'm going to run this, but before that, you can see here I have explained a little bit what are these parameters. And the no underscore above equals 0.5. It means that the tokens which appear in more than 50% of the summaries will be dropped. So what we want to try to do now is to remove the words that are way too ubiquitous, meaning the words that appear everywhere in every summary. Because at the end of the day, that word is not carrying any particular information because it's everywhere. So that's what we are trying to do here. And believe me, I tweaked this parameter a little bit, and it gave very different results. So it's really an important parameter, even if it's deep in a function, etc. You really have to be careful about that parameter. So I'm going to run this, and then we can see the result. So we see that initially, like I told you before, we have 3,843 words or tokens. And after we have run this filtering, we have only 1,437. And here it's an example. It's for the first bag of words, for the first well. And it shows the words are numbered 0, 1, 2, etc. And then you see the frequency that word, which is referenced with this ID, is appearing in a bag of words. So here you have the start of the bag of words corresponding to this index. So it starts analysis, API, attempt, barrier, pairing, etc. It continues. And you see that we have one time the word analysis, one time API, one time attempt, two times barrier, etc. So at this point, I was like thinking, oh, that's removing a lot, right? We are removing more than half of the tokens. So we'll see what happens. I tried a little different solutions. Or different scenarios. So yeah, but I thought this one was an okay one. So what I want to introduce here also is the notion of perplexity, which you see here in the text. And I can say here that increasing the value for the no above parameter also increases the perplexity value. The model will have more difficulty to generate the different topics. The topics will overlap significantly. Exactly. So, because if you keep the words that appear everywhere, then the topic modeling will have much more troubles to differentiate different topics. So that's also something to keep in mind. So you see here, there is a lot of trial and error, and you have to run different scenarios with different parameter values until you find something which tends to have a result which can be used by what you want to do. Of course, it's different from case to case. A bit, the next step about topic modeling. I have to look at the time, but I think we're doing good. What is topic modeling? So my friend GPT-3 answered, it's uncovering the hidden or latent topics across a set of documents. Okay. Also, a given number of themes or topics will be generated by grouping words which have an apparent connected meaning. Here, the context thing we were talking about. Topic modeling has similarities to clustering, but topic models can also be used for understanding, exploring, and visualizing a collection of texts. So, in fact, I think it's a good comparison, a good comparison to say that topic modeling is similar to clustering. Then you understand, to unsupervised clustering, you understand a little bit how things are grouped in a way which makes sense to your parameters and function and algorithm that you choose. So this is an interesting comparison. So, sorry, I have just to drink a little bit of water. In the next step, we are going to calculate coherence values for a various number of topics. In this way, we can select which number of topics seem the most suitable. So remember, we have now a corpus with well report summaries that have been thinned down quite a lot. But still, we want to see if we can generate different topics out of this corpus. And we don't really know how many topics could be extracted from this corpus. 2 or 4 or 5, 10, we don't really know. So we are going to run this function below, which then you will have to you can read more about it in the GenSim documentation. And it's using LDA modeling. So LDA is to actually generate topic modeling. I will speak a bit more of LDA just in a minute. And here I have to stop running the different cells because the next one, which is actually running the function, takes 3 minutes. So I will just go through the rest of the notebook without running the cells, but I will try to make clear where we are. So I have run here the function. That's the next one, which takes, for my machine, takes 3 minutes. So it depends a little bit. I can just mention that here we are using the LDA multi-core. So it should be a bit better than if you just use the LDA. So here I have, on my machine, I have 4 cores. So I put 3 workers to have 1 core free. And so it's supposed to help, but I can say that it, for me, 3 minutes was okay, but as I said, the corpus is not that large. Then we inspect the different results we have, and we can see that we have actually, we have run different scenarios for the topic modeling. First of all, we are running, we are telling it that we don't want less than 4 topics. We don't want more than 10 topics. And we are going through 4 topics, 5 topics, 6 topics, etc. And then there are other parameters, like it's the typical machine learning tweaking parameters. Then you have an alpha parameter, a random seed. So please read also about that. These are important. You change, of course, if you have different values, that will give you different results. But here, what I did, actually, I kept the parametering that Michael Doling was using in his notebook. So, but of course, there are other ways to, or other parameters that you can, other values that you can use for these parameters. Here is the result of this function that we just ran. So you see that we have a classification from top values of covariance to less covariance. Now a word about covariance. This is also getting interesting, or for me it was getting interesting. GPT-3 says a covariance scores of 1 indicates that the documents are completely coherent, meaning that they are about the same topic. A coherency score of 0 indicates that the documents are completely incoherent, meaning that they are about completely different topics. Okay, so intuitively, I would say that I would rather want to have a coherency score close to 0, right? Because I would like to have completely different topics in my corpus. But do we really? Because this is well-report summaries we are talking about. So it's intrinsically, it's the same sort of information or type of information we have throughout these wells. It's about wells, it's about drilling, etc. So what is the correct value for the coherency? And here I must say that I'm not quite sure, but if somebody knows about coherency at this point for topic modeling, or you have a reference or something, please let me know. I would be interested to read more about it. So we see here that the best, the highest, so again, should we take the highest, the lowest? But we'll see that actually we have to stick with the highest lower value of coherence. The best result was, or the best score was for 9 topics. And I was thinking 9 topics is a little bit too much, too many. So I took the next one, which is 5 topics. So we admit that the best way to, or the best number of topics for our corpus is 5. Okay. Now a few words about LDA, or maybe I think we could take a short break here, because then we go into the visualization. So we could have a break of 5 minutes, so until 14:20. So see you in a little bit. Okay, we are back. So that's the last part now. Yeah, you can see that this notebook is a bit, it can get quite intensive. So definitely the best, which I forgot to say at the start, I'm really sorry, would have been to not try to code along, but I guess you figured that out by now. But again, yeah, please post your questions in the Slack channel, and if you have issues, I will do what I can to try to help you figure out the solution. All right, so I hope everybody hears me. I'm just checking. Okay, sorry for that. So a few words about LDA model. LDA, again, I asked GPT-3, so it's quite short answers. LDA stands for Latent Dirichlet Allocation. Not sure if I pronounced that correctly, but you can tell me. And it's a topic model for discovering the topics in a collection of documents. So it's just actually a way to do topic modeling. The main characteristics of LDA are that it does not assume a fixed number of topics, and it works well with very large collections of documents. So that's also an extra answer for GPT-3. So here actually we established that we want to try with 5 topics. And I don't know if we can call our collection of documents or corpus to be very large. But anyhow, let's have a look. So again, I'm not going to run these cells because it takes a little bit more time. But here we are basically creating our topic modeling in this cell here. And this cell, I think for me, took about 1 minute or less than 1 minute to run. I have to say that I had to spend some time tweaking the parameters, especially the random state and the alpha parameter. So Finally, I found that these parameters were giving a satisfactory result. It's also that I didn't try for days, only for hours. But you will see what happens now. So of course, these parameters, again, read the documentation and you have to try several different things to see how that goes. So now we have created our 5 different topics, which here are numbered from 0 to 4. And we are printing here with this cell the most frequent words in our topics. This number here, the 0, 1, 2, 3, 4, I think it's random. It doesn't really mean anything. But you can see that for topic 0, we have these words are the main words. We have day, we have DST, temperature, gravity, etc. Topic number 1, we have the main words prospect, stir, quality, SNAD, Statfjord pressure, pilot, etc. Topic 2, we have section, drilling, sand, seawater, log, Jurassic, salt, porosity. Topic 3, we have pressure, contact, structure, sidetrack, appraisal, etc. Topic 4, we have rock, sand, shale, sequence, age, source, part, claystone, etc. So here I was a bit puzzled because my knowledge of wells is a bit general. But bear with me. So I had, I use a joker here, which is that I had to ask somebody who knows more about wells than me what these different topics could be if we just look at these words now. Here I have to say that that's exactly also a very important parameter, if I can call it that. It's a very important aspect that when you do machine learning, you better have somebody who is an expert in the domain you are doing machine learning in, because otherwise you have results, you don't really know what they are, and then you draw conclusions and maybe you're completely besides the point. So here I had to ask Rob to help me determine the different topics, what they could be about. And then also, what I have to say is that between I ran this with Rob a couple of weeks ago until yesterday, the NPD has added a few new wells, so well report summaries, in the data sets, and that changed the game quite a bit. So a couple of weeks ago, we had 6 topics, and now we have 5, which were the best way of doing it. And also we found that it was a bit less evident to find out which were which. But let's say that the first one, so the topic number 0, could be about well test. The topic number 1 could be about prospect and exploration. The topic number 2, honestly, I'm not sure. The topic number 3 could be about fluid and contact. And the topic number 4 could be about stratigraphy. So since I was running this a bit late yesterday evening, I had no new input from Rob. So don't blame him, but me for my choices. So before we move on to the visualization, the final visualization, I want to say a few words about perplexity that we saw before. And perplexity is a measure of how well a topic model represents a collection of documents. And a bit paradoxically, you want this perplexity to be as low as possible. You want your model to be as less perplexed as possible. So you want your model to be able to recognize the topics as best as possible. So you want it to be not perplexed. I hope that was a clear explanation. So here we have this score of -625. So of course, when I ran this first, I didn't know what this -625 was as a value. So I ran different number of topics, etc. And I saw that if suddenly I was doing things very differently with the parameterization or something, I was increasing the perplexity. And sometimes it was slightly, and sometimes it was more significantly, but it was still around 6, 6.1, etc. I only had a big jump of the perplexity when I decided to run a scenario where I do not remove the ubiquitous words. So you remember before we had this filter extremes, and I decided to leave the words, all of them, whether they appear everywhere or not. And then the perplexity jumped to -4 something. So definitely to leave all the words, all the ubiquitous words, provoked that the topic modeling got confused, was not able to clearly define different topics. So at least there I was quite cool and that was quite evident. But check it out and let us know. Here I again compute a covariance score. So I think here the covariance score is higher because I am not using the same parameters that we used on the covariance score that to create to give us an indication of the best number of topics. Here, for example, I have only 10 passes. Is that enough? So you see that again, you have to experiment with these parameters. But in a way, I was a bit more satisfied with this covariance score because it's higher, so it denoted that it recognized that our corpus is about the same subject, in fact, better than before when we had 0.3. Finally, we go into the visualization. And this is the PyLDA visualization I was talking about. And here we see our 5 topics that are represented by 5 circles. So the visualization is completely interactive. And unfortunately, the number on the circle is not corresponding to the number we had before in the list here, in the result. But it is the same groups. It's just the number not matching. So we just look at this one. And I will explain the different parameters in this visualization in a minute. But here is the topic number 1, which we recognize as before, day, day, temperature, etc. And I have written every circle what they may represent here. So the first circle, the circle number 1, is about what we define as about well test or well testing. The second one, which we have, you see the main words. So I can just say that in red, it's the words that are within that topic compared to in blue, the overall corpus. So you see that in the topic number 2, we have more than half of the words pressure for the whole corpus. Then in this circle 2 would correspond to, for us, what we define as fluid and contact. So of course, please comment if you think it's it's not that at all. Go ahead, take a screenshot and write what you think. Number 3, here that was the one that I was actually not sure about is section drilling sand, seawater. I was like, we will see about that one in a minute. But the number 3, I was not too sure about that. Number 4, we were with rock sand shale sequence age. That's the one I thought was about stratigraphy. Well, I was thinking that especially the sequence word is very present in this topic. And then number 5, it would be the one about prospects and also maybe exploration. So now we have, I can tell you about this lambda parameter, but quickly said, I have a note here. So you can read this, but it's better maybe or shorter or more understandable to first read that one. If lambda is 0, it means very specific words which are very specific to a given topic. In some cases, the topic will contain exclusively that word. So when you set lambda 0 value to 0, you will really go into the specific. And if you set lambda to 1, which is the opposite, you are in generic words, meaning words which appear in a given topic but are also common in the rest of the corpus. So let's have a look again at this number 3 circle that I was not so sure about. And I put this lambda here to 0. So you see that, okay, this topic has most of the words for Zechstein and for salt and cement and Rotlingener. So I don't know, is it like a Permian topic only? I don't know. I really would like to know, actually. So if you look at this and you really know, it's about this, that, and the other, just write it into the Slack what you think the circle number 3 is. And if you check for the, in comparison to the whole collection of words, number 3 here, it has quite, let me see. Yeah, for example, here you see that it definitely has most of the words for salt, or the word salt is contained almost exclusively in this topic. And if you check for porosity, well, you can see that there is quite a number of porosity words in this topic, but they are also appearing in the others that you can see. So it's also very nice, this visualization, because you can actually go through different words, and then you can see where they, in the other topics, where they appear. So I have to think if I should say more about that. Yeah, okay, we have here, well, it's always, this is this PC1 and PC2. I have explained a little bit here what it is about. It's referring to, as we expected, to principal component analysis. The PC1 axis is the axis in the principal direction along which the samples show the largest variation, and the PC2 axis is the second most important direction for variation in the data. So we, of course, you can expect that you are in a multi-dimensional space, and this is reduced now to 2 space or 2D space, where we observe the most variation along the 2 axes that are the most relevant. So that was about this axis. So yeah, I think I'm slowly reaching the end of this presentation. this visualization allows you to have an idea what kind of topics you are covering in your corpus. Of course, what would be really cool is to take something really large, like the well report summaries of UK, Norway, Denmark, everywhere, and try to run the same sort of notebook. And that would be a nice project to continue with. And as conclusions, I would say that, like I mentioned before, it's really important to have a domain expert in your data science team to be able to know what the result, if your results make sense, are relevant, are usable. And of course, this was only an introduction. So you have seen that there is a lot of documentation, there is a lot of parametering, fine-tuning, etc. And that was just one way to do it. So please, if you find that something should be tried differently, etc., comment and ask, write comments and ask questions in the Slack channel. I would like to thank, as a final word, I would like to thank Agile Scientific and Matt and Rob for inviting me to present this at the Transform 2021 conference. It was a unique opportunity and a first timer for me. I hope you enjoyed this Jupyter Notebook and that you are now curious about NLP. And yeah, I will see you soon on the Slack channel. So over and out for me.
Okay, well, that was great. Thank you very much, Anne. Feel free to switch your video on just as we say goodbye. I want to thank Anne Estoppey because we're both geologists, and hopefully this is going to inspire other geologists to jump right into machine learning and natural language processing. So thank you very much, Anne. I also want to thank Studio X, who sponsored Transform 2021, and of course the whole Software Underground community, without which this would not be happening. So with that, I think Anne will be going over to the T21 MUN Machine Learning Slack channel to try and answer some questions. If you've been watching this on YouTube, don't forget to like and subscribe, and we'll see you in the next video. Bye-bye, everyone.